Hare Krishna. Now in this video we are going to learn about symmetrical complementary functions of linear differential equations. First chapter. What is a symmetrical function? It is a group of terms. We can write the symmetrical function as P upon A is equal to Q upon B is equal to R upon C. That is, the equations are in a ratio form. Now if someone asks what is the general form of a symmetrical function, then it is dx by p is equal to dy by q is equal to dz by dz by r. This is the general form of symmetrical equations. That is, the questions will be asked in the ratio form in this manner, in which p, q, r are the functions of x, y, z. Okay, now solving the first question. What the first question is, in the exam you will be asked, find the solution of symmetric simultaneous equation dx by 1 is equal to dy by 1 is equal to dz by 1. Now how to find out the answer? You have to first group two numbers. You have to first solve two ratios together. First, in order to get the first answer, we will group dx by 1 and dy by 1. Dx by 1 is equal to dy by 1. Cross multiplying it will 1 will here 1 dx is equal to 1 dy. Now integrating on both the sides, what is the integration of 1? 1 is a constant, so integration of constant is constant into variable. I will write here integration of constant is equal to constant into variable. Integration of 1 so integration of 1 dx is equal to 1 into x, and here 1 into y plus c. Now we can also write it as x minus y is equal to c. Shifting the y to the left side of the equation, we get this is the first answer. Now second answer is, we'll group dy by 1 to dz by 1. Dy by 1 to dz by 1. As you have solved previously, first cross multiplying, we'll get 1 dy is equal to 1 dz. Integration on both the sides, integration of 1 dy is equal to integration of 1 dz. Now again, constant into variable, integration of I will write here integration of 1 dy is equal to constant is 1 into variable y, so it will be y. Likewise, integration of 1 dz is equal to 1 into z plus c. Now again, shifting the z to the left side of the equation, you get y minus z is equal to c. Now if you look closely here, dx by 1 is equal to dy by 1, the answer is x minus y is equal to c. If we ignore, if we logically see, then if we ignore the d by 1, then it will be x is equal to y, and then shifting the y to the left side, and it will be x minus y is equal to 0. 0 is a constant, so x minus y is equal to c. Likewise, if we say y, if we shift the z to the left side, then it will be y minus z is equal to 0, and we can write 0 again as constant, so y minus z is equal to c. So again, in order to save our time while solving MCQs, we can say the what is the next part is this: we have to group dx by 1 to dz by 1. We can by using shortcut we can say x minus z is equal to c. So by solving this question we will get 3 answers. Now solving the second question, if you are asked in the exam to solve the symmetric equation dx by x is equal to dy by y is equal to dz by z, then the process is: first grouping dx by x and dy by y. As we have solved previously, we got 3 answers. Here we will also get 3 answers. So first, dx by x is equal to dy by y. We can also write them as 1 upon x dx is equal to 1 upon y dy. There is no need of cross multiplying, as the both the terms are same. Here x and x are same, y and y are same. So now integrating on both the sides will get integration of 1 upon x dx is equal to integration of 1 upon y dy. Now integration of 1 upon x is equal to log x. So similarly, it will be log x is equal to log y plus c. Now shifting the log y to the right side of the equation, will get log x minus log y is equal to c. Now here log a minus b will come. Their formula is log a minus log b is equal to log a upon b. So it will be log, here what is the a term? A term is the x and b term is the y. So it will be log x upon y is equal to, now here c represents a constant. If we write log c, then also the log of c will also be a value, numerical value, which is also be termed as a constant. So we can also write here as log c. Now log is on both the sides, so cancelling log will get x upon y is equal to c. Shifting y to the right side will get x is equal to yc. This is the first answer. Similarly, solving the second, what is the second? It is, now the second answer, for second answer we will group dy by y to dz by z ratios. We will group dy by y is equal to dz by z. integration we can also write it as 1 upon y dy is equal to 1 upon z dz. Integrating on both the sides, integration of 1 upon y dy is equal to integration of 1 upon z dz. Now as you have seen previously, integration of 1 upon y we can also write it as dy log y. The answer is log y. So we can write here log y is equal to log z plus c. Now log y minus log z, shifting log to the right side, get log y minus log z is equal to c. Now as you have seen previously, log a minus b is equal to log a upon b. Here a is y and b is z, so we'll get log y upon z is equal to, again we can write log c. It will not matter because the final answer will be a numerical value which we'll call a constant. Cutting both the log terms, log is same on both the sides, so cutting log we'll get y upon z is equal to c. Shifting z to the right side of the equation, we'll get y is equal to zc. This is the second answer. Similarly, if we can look closely, then here dy by y is equal to dz by z. What the answer we get is y is equal to zc. Y is equal to zc. Here in dx upon x is equal to dy by y. Here we get x is equal to yc. The answer is x is equal to yc. So if we write integration of dx by x, integration dx by x is equal to dz by z, then the answer will be x is equal to zc. This is a shortcut which we will use in order to save the time when solving MCQs. We will solve the first two answers, and when we learn the pattern of the answers, we can assume the third answer. So I hope you have understood. Now we are going to find how to solve the symmetric equation by considering the first two ratios. This is a part of the symmetrical equations in the exam. If you will be asked to find the symmetrical equations by only considering the first two ratios, it means that if we solve the first question, dx by y square is equal to dy by x square is equal to dz by x square y square z cube. It means you have to ignore the dz term. You have to only solve dx upon y square and dy by y square. These are the first two ratios. So now solving, we will get first cross multiplying x, here it by cross multiplying we will get x square dx is equal to y square dy. Now integrating on both the sides, we will get integration of x square dx is equal to integration of y square dy. Now as you have seen previously in the integration formulas video, integration of x raised to n is equal to x raised to n plus 1 upon n plus 1 plus c. So now here it will be x 2 plus 1 upon, here the value of n is 2, upon 2 plus 1 is equal to, here again y 2 plus 1 upon 2 plus 1 plus c. Here 2 plus 1 is 3, so it will be x cube upon 3 is equal to y cube upon 3 plus c. Now shifting the y cube by 3 part to the left side of the equation, we will get s cube by 3 minus y cube by 3 is equal to c. The 3 is common in this part of taking, so taking 3 common, will get x cube minus y cube upon 3 is equal to c. Now here how to cancel out the 3 part? The only way to cancel out the 3 part is to multiply both the sides by 3. So write multiplying both the sides by 3. It will be 3x cube minus y cube upon 3 is equal to 3c. Cancelling the 3 and 3 part, see 3 ones are 3, we will get final answer x cube minus y cube is equal to c. This is the final answer, because 3c, 3 multiplied by any value, constant is any value, 3 multiplied by any value, it will be a significant value which will at last finally be a constant. So the final answer is x cube minus y cube is equal to 3. If we multiply or divide by constant, the final will be constant. Or we add or subtract a constant, the final answer will also be a constant. Now solving the second question. Here we have to solve these ratios by considering only the first two ratios. Now what are the first two ratios? Dx by y square is equal to dy by minus xy. Now in order to simply solve the question, here we have to first look closely. We will see that y and y are common. Y and y are common. So cancelling the y terms, here y is 2 times repeated, y raised to 2, and here y is only 1 time repeated. So cutting, cancelling one y with another y, will get the final, will get dx by y is equal to dy upon minus x. Here 2 times y was repeated, so cancelling the so y was 2 times repeated, so cancelling the second y, and here y was only 1 times repeated, so cancelling both the y's together, here only one y will remain. Now as dx by y is equal to dy upon minus x, again cross multiplying together, you get minus x dx is equal to y dy. Now integrating on both the sides, will get minus x dx is equal to integration of y dy. Integration of x is x raised to n plus 1 upon n plus 1. So minus sign will remain as it is, and x raised to, if nothing is given, then we can assume that raised to power 1. N is 1, so x raised square 1 plus 1 upon x square upon 2 minus x square upon 2 is equal to, here y square upon 2 plus c. For someone who doesn't know the integration of x raised to n, it is integration of y raised to n, it will, there is no difference between x raised to n or y raised to n. At last both are variables. Integration of y raised to n is equal to y raised to n plus 1. What is the value of n? It is 1. So y 1 plus 1 upon n plus 1. So it will be y square upon 2. Now shifting y square by 2 to the left side, a positive sign is there, so the left side it will be minus sign, negative sign. So minus x square by 2 minus y square by 2 is equal to c. Taking minus sign common, we will get x square minus plus y square upon, taking 2 also common, because 2 is common in the denominator, it will be is equal to c. Now in order to delete the 2 from the denominator side, as we have done in the previous sum, we have to multiply with with 2. So it will be minus 2, minus sign is there, so multiply by 2 into 2 x square plus y square upon 2 is equal to 2c. Multiplying on both sides, cancelling 2, will get minus x square minus y square is equal to constant. Anything multiplied by constant, the final answer will be constant, so it will be minus x square minus y square is equal to c. Now this is the final answer, but if in the MCQ type, if this you will not find this type of answer, then what we will do, multiplying throughout by minus 1. So minus 1 into minus x square, it will be plus x square, it will be plus y square, and anything multiplied by constant, the final will be a constant. So now this is the final answer, and this will be asked in the MCQ options. Now we are going to solve the last question by considering again first two ratios. The first two ratios are dx upon y square z is equal to dy upon x square z. Now again z and z both are common, so cancelling both together, we'll get dx upon y square is equal to dy upon x square. Cross multiplying, we'll get integration of, and cross multiplying and integrating of both sides, we'll get x square dx is equal to integration of y square dy. Now here raised to power is 2, raised to power is 2, by applying the x raised to n formula, n, the value of n is equal to 2. I'll write here again, integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So it will be x cube upon 3 is equal to y cube upon 3 plus c. Again shifting the y cube by 3 to the left side, will get x cube by 3 minus y cube by 3 is equal to c. Taking 3 part common, x cube minus y cube upon 3, taking is equal to c. Now as we have solved previously, the same time we have to again multiply with 3 in order to cancel out the 3 part, remove the 3 part, x cube minus y cube upon 3 is equal to, as we have multiplied on both sides by 3, it will be a 3c. Cancelling out 3, we'll get x cube minus y cube is equal to c. This is a final answer because anything multiplied by constant is constant. Any value multiplied by constant is constant. So I hope you have understood. If there are any problems, then please ask in the comment section. Hare Krishna.